The cosmic clock has been ticking for almost 14 billion years, and an almost infinite number of worlds have been born since then. One of them is our own, Mother Earth. When we look into the starry sky, into the seemingly endless expanses, the question arises: are we really alone out there? Why have we still not been able to discover the smallest trace of extraterrestrial life? So what's holding them back? Welcome to the so-called Fermi Paradox. You may be wondering how many stars are there in the observable universe, and how many of the planets surrounding these stars could be habitable. First, let's wrap our heads around the vastness of the observable universe. Estimating the exact number of stars and planets is no easy feat, but astronomers have ventured into the realm of estimates based on observations and theoretical models. Our observable universe is home to an astounding 2 trillion galaxies, each boasting hundreds of billions to trillions of stars, making for an astonishing total of around 200 sextillion stars. That's a mind-boggling 2 followed by 23 zeros. Now let's shift our focus to planets. Counting planets is a trickier endeavor because it depends on how many planets orbit each of those countless stars. Thanks to our exploration of exoplanets in our very own Milky Way, we've learned that planets are anything but rare. In fact, there might be hundreds of billions to trillions of planets in our galaxy alone. But hold on to your space helmets. We're just getting started. When we extrapolate this wealth of planets across the entire observable universe, we're looking at numbers in the ballpark of 10 to the power of 24 or even more. Don't worry, it's not you. No one can imagine such absurd numbers. Now you might be wondering how many of these planets are suitable for life. That's where it gets even more fascinating. The concept of habitability depends on a multitude of factors, such as a planet's distance from its star, its size, its atmosphere, and many other variables. Scientists have identified some potentially habitable exoplanets, particularly those located in the habitable zone around their stars. The best we can do is make rough estimates, suggesting there could be millions or even billions of potentially habitable planets across the universe. But remember, what we consider habitable can vary, as it's rooted in our understanding of life on Earth. Now, let's address the elephant in the room. If there are so many potentially life-friendly planets out there, why haven't we discovered any signs of extraterrestrial life, or why haven't they found us? This perplexing conundrum is known as the Fermi Paradox, and it's a cosmic head-scratcher. One possible explanation is the concept of the Great Filter. Just as humanity grapples with existential threats like nuclear weapons and environmental degradation, advanced civilizations elsewhere might face similar self-destructive challenges. The Great Filter represents a hypothetical obstacle that dramatically reduces the odds of a civilization reaching the point where they can reach other cosmic neighbors. Among the scenarios within the Great Filter concept is the idea that the development of advanced technologies and the exploitation of resources could lead to a civilization's downfall, whether through war, environmental collapse, or other negative consequences of technological progress. But what if advanced civilizations have figured out how to bypass these challenges or are simply extraordinarily rare? They could be thriving at vast distances, beyond our current detection capabilities. The universe, you see, is mind-bogglingly vast. Exploring and studying distant exoplanets is no walk in the cosmic park, even with our advanced technology. Our current methods are most effective for stars relatively close to Earth. Our search for extraterrestrial life is constrained by the time and resources dedicated to this monumental task. While the search for extraterrestrial intelligence, known as SETI, has been ongoing for decades, it's covered only a fraction of the observable universe. But let's not forget, the timing of technological advancement may differ among civilizations, making their detection a matter of cosmic synchronization. Another twist in the cosmic tale is that life as we know it might be relatively rare in the universe. Even with countless potentially habitable planets, the conditions required for life to emerge and evolve could be rather unusual. Extraterrestrial life may not fit our preconceived notions. It might exist in forms or environments we haven't even considered or can't easily detect. Our current methods for detecting exoplanets and extraterrestrial life are based on our Earth-centric understanding. Alien life could have vastly different biochemistry or be so alien that it remains undetected. And let's not overlook the vast cosmic distances. Even if advanced civilizations exist, interstellar communication is a Herculean challenge. Signals might not have reached us, or we might not be searching in the right way or at the right time. But wait, could our first contact with extraterrestrial life be with intelligent machines rather than biological beings? This intriguing notion has the potential to shed new light on the Fermi Paradox. Imagine a scenario where we come in contact with AI or self-replicating probes from distant civilizations before ever meeting biological entities. It's a concept that challenges some fundamental aspects of the Fermi Paradox and could reshape our understanding of how civilizations explore the cosmos. We humans, from planet Earth, are developing artificial intelligence and building unmanned drones as well, so perhaps we're already on that path. Well, is it possible that we find ourselves at the forefront of technological advancement in the cosmos? Could the responsibility for venturing out into the cosmic unknown and taking that pivotal first step toward colonization have to be ours? Less advanced civilizations may eventually stumble upon us, and the role of discovery could be reversed, with them finding us before we actively seek out others. It's a concept that could reshape our understanding of our place in the universe. In the end, the quest for extraterrestrial life is an evolving field. Scientists are constantly refining their methods and approaches, inching us closer to unlocking the cosmic mysteries. So, as we conclude this journey through the universe's grandeur, the Fermi Paradox remains a tantalizing puzzle. Our understanding of the cosmos is ever evolving, and who knows what future discoveries will unveil. Until then, we'll keep our eyes on the stars and our curiosity ignited. Did you like this video? Then here are 2 more for you. If you don't want to miss any more exciting videos about our incredible world, subscribe to the channel and activate the bell.